Hello, my name is Helga Stopper. I'm a professor for toxicology at the Institute of Pharmacology and Toxicology of the University of Würzburg, which is in Germany. The topic of this lecture is microplastics. I will give an introduction on the topic of microplastics in the environment, and at several points of this presentation there will be the opportunity to pause and do some literature research or internet research, and I will put forward some questions that you could answer by these tasks. Microplastics are plastic particles that are smaller than 5 millimeters in size, and they originate from various sources, and they are now widely distributed throughout the environment. They enter the environment by various pathways, for example, discarded plastic items, wastewater, and atmospheric deposition. Ocean currents, atmospheric transport, and human activities contribute to the global distribution and transport of microplastics. Microplastic particles are now found in oceans, lakes, rivers, soils, and even remote regions such as polar ice caps and mountain ranges. And I would like to cite the authors of a recent paper by Richon et al., who said, "Recent global assessments reveal that microplastics could have a significant impact on biogeochemical cycles and microbial food chains within ocean ecosystems that may be equivalent to those of climate change." There are primary and secondary sources of microplastics. Primary sources refers to intentionally manufactured small plastic particles, also called microbeads, that are used in personal care products such as facial scrubs and toothpaste, and also to plastic pellets used in manufacturing processes. Secondary sources means fragmentation of larger plastic items such as bottles, bags, and packaging due to UV radiation and mechanical abrasion. Microplastics come in various shapes and sizes, including fibers, fragments, pellets, and films, each probably with its own environmental fate and impact. Already very well known is the impact on marine life. Marine organisms can ingest microplastics, mistaking them for food, leading to physical harm, digestive blockages, and malnutrition. Numerous studies have documented harmful effects of microplastics on marine species such as fish, seabirds, sea turtles, and marine mammals. Microplastics can accumulate in the tissues of marine organisms and increase concentrations along the food chain. So let's first look at microplastic in the ocean. Every year, millions of tons of plastic end up in the oceans. The area of the Pacific Ocean garbage patch is now 3 times the size of France. This is the largest accumulation of plastic waste in the ocean. It takes hundreds to thousands of years for it to completely decompose. It is estimated that each year 100,000 marine animals drown or suffocate due to plastic items. Currents and friction processes create even smaller particles. Below 5 millimeters in size, these are called microplastics. These small particles are a big problem in the sea because marine animals mistake them for food, such as plankton. This graph from the publication by Richon and co-authors shows the degradation of plastic into micro and nanoparticles and the impact of the various size particles on different organisms in the ocean. Are microplastics toxic for humans? This is not an entirely solved question at this point. The German Federal Office for Risk Assessment, the BfR, assumes that microplastics do not endanger health. Apparently, the human body excretes the microplastic particles. However, a study from 2024 found a doubled risk for myocardial infarction, stroke, or death from any reason in patients who had micro and nanoplastic particles in their carotid artery plaques. Authors state that this is the first study which associated the plastic contamination with human diseases, and that more studies are needed to confirm the results. For submicroplastics and nanoplastics, it is not yet known with certainty whether and in what quantities they can actually enter the human body. But plastic also contains plasticizers and other chemicals which can leak out of the plastic material and could by themselves pose a threat. In addition, many other organic substances accumulate on the surface of microplastics, including long-lasting, hardly degradable environmental toxins like hydrocarbons or the pesticide DDT. Already in 2015, scientists from the Hamburg University of Applied Sciences found that microplastics contain 3 to 4 times as many toxins as the seabed next to them. Here, I would like you to plan about 30 minutes for research on the internet to find one or more examples of affected marine wildlife. And in the following slides, I will show an example. I am sure that you have found many striking examples of how microplastic affects wildlife in the ocean, but I would like to show you this example, microplastics in coral reef ecosystems. And I would like to point out this publication where this is described very well. Microplastic particles in the coral reef destroy the coral polyps and hinder the natural coral growth. It has been found that microplastic hinders oxygen supply and photosynthesis in the coral reef ecosystems. The effects of microplastics include ingestion problems, blockage of digestive tracts, and immature death of coral polyps. In the shallow ocean water, coral reefs in the tropical regions are most affected. Coming back to human health concerns and exposure. Humans may be exposed to microplastics through ingestion of contaminated seafood, drinking water, and food items, as well as inhalation of airborne particles. Emerging research suggests potential health risks, including inflammation, oxidative stress, and the transfer of harmful chemicals associated with microplastics. While the full extent of health risks is still being investigated, there is growing concern over the potential long-term effects of microplastic exposure on human health. And I would like you to pause again here for about 30 minutes and try to find some studies on the internet regarding microplastic contamination in drinking water or foodstuff. The following slides will then show examples and also provide literature references. Here are some very useful sources for information for how microplastics are found in water drinks and food items and how many of them. Various food products can be contaminated with microplastics, and for example, this includes water and beverages, it includes seafood, plants even, like fruits and vegetables, and also salt, sugar and honey and other food items. It has been estimated that 10% of the 8.3 billion tons of plastic produced globally to date has accumulated in marine and freshwater systems as plastic waste. I would like to point out one particular study. This study is placed in South Wales, UK, and they found up to 650 million microplastic particles to enter one wastewater treatment every day. These particles ended up in the sewage sludge, making up roughly 1% of the total weight. Sewage sludge is expensive to dispose of, and it is rich in nutrients. It is therefore used as an organic fertilizer in the US and Europe. As the authors state, the number of microplastics that end up on farmland is probably even underestimated. This source has gathered information for many publications, and they say that there are about 28 microplastic particles per liter of beer. With seafood, one may consume more than 50,000 particles of microplastics per year as an average consumer, which is, as they say, equivalent to the amount of 17 credit cards. Fruits and vegetables absorb microplastics through their root system, and they enter seeds, leaves and fruit depending on the microplastic size. Around 2,000 microplastic particles per year can be consumed alone from salt. These were just a few examples, and I'm sure you found some others. Altogether, they show that microplastics are everywhere, also in our food and drinks. What should be done in the future? Future research should focus on understanding the long-term environmental and health effects of microplastics. We need regular monitoring of microplastic pollution, assessing the effectiveness of measures, and also we need to raise public awareness. And we definitely need innovative solutions for reducing microplastic pollution. This may include the development of biodegradable plastics, of alternative materials, and also advanced waste management technologies to minimize the release of microplastics into the environment. But also ocean cleanup strategies will be needed in addition to the reduction of newly added plastic waste. And regarding the relevance of ocean cleanup strategies, I would like you to take a look at this paper, which might again take about 30 minutes. In this graph taken from the paper by Richon et al., you can see on the left side the amount of macroplastic and on the right side the amount of microplastic in the ocean surface layer. And there are three scenarios in each of the pictures. Number one is business as usual, that is, the emission increases as it has so far. Number two is 80% emission reduction from 2020 on. And number three is 80% emission reduction from 2020 on, combined with a 12% annual cleanup of microplastics from the ocean. And it shows that even if we stop putting plastic waste into the ocean right now, microplastic could still double by mid-century due to degradation of plastic that is already present. Therefore, in addition to reducing new plastic pollution, the existing plastic waste needs to be removed. The take-home message from this lecture is: microplastics are pollutants that pose significant risks to the environment. Further research is needed regarding health risks for humans. Plastic production and consumption should be reduced, and plastic waste urgently requires improved management. Thank you for participating in this activity.